changed. Turns out things have not really changed. And as we were having this conference, there were some route hijacks also happening, but weirdly, this way, unused address space being hijacked and propagated out there. So I will cover this when I talk about ROA and ROV. But why do we still keep seeing BGP incidents or headlines out there? Let's go back to fundamentals. We love our decentralized internet, which means there's no one in charge. The fact that there's no one in charge means there's no reference point for me. When I look at a BGP table, if I'm sitting in Brisbane, I have a very different view of the BGP table if I'm looking at it here in South Africa, right? So there is no reference point for what is right, right? BGP still seems to work, right? Internet routing still works by rumor, right? It's like playing a game, me telling Portia I'm from Bhutan, ask her to whisper that across, and by the time it comes this side, it might say she's from Japan. Right. So that's how internet works. We assume everyone will be honest as it transits, right? Which doesn't seem to be the case. And the fundamental design of routing is it works in reverse. I tell you what I know, right? What I tell you dictates what you can send me. What you tell me dictates what I can send you. What's to stop me from pretending to be Portia and say, hey, I'm Portia from South Africa? Whatever parcel was supposed to come to her might end up coming to me. And that's how route hijacks work. Right? The fundamental design allows the hijacks. And like it or not, we still don't have the evil bit in every BGP update. I wish there was an evil bit. Professor Steve Bellevin wrote an April Fool's RFC 3514, 20-something years ago, where he said, hey, you bad actors, please mark your packets with the evil bit so that I know how to drop it. Sadly, we still don't have that, right? So given all these fundamental design issues, given the fact that the internet was designed for trusted ecosystem, we need a lot of puzzle pieces to try and secure the internet routing. The first puzzle piece I want to touch upon is RFC 8212. BGP by default is a very permissive protocol, right? Whatever, if I have two upstreams, or if I have more than one eBGP peer, whatever I learn from one, without me telling BGP what to do, it gets sent to the others. Right? That's the default how BGP operates. And that's where we see most of the route leaks happen because of that inherent BGP behavior. And to stop that or to change that, RFC 8212 was written, right? The idea being if there's no explicit inbound or outbound policy, don't accept route. You can accept it, put it in your adjacency RIP, but don't use it for your best path selection, or don't send or announce routes to your eBGP peers. So you need explicit import, explicit export policy before you can receive or announce routes. But the problem with RFC 8212 is, what if I have a policy which says send everything, receive everything? Right? So it is in itself not a full-fledged, well-thought knob, but it's still something, right? And as you can see, vendors that have implemented it, iOS XR, it's there by default. Nokia's SROS, it's there by default. The routing daemons seem to always do better than the big vendors, right? You look at Bird, it had it from a long time. You look at FRR, even RouterOS has 8212, MikroTik for those. And if you look at Arista, Juniper, and even the classic iOS XE, it's not enabled by default, but the knobs are available for you to enable it if you want. So back to basics again. So what do we do? Typically, BGP, before I bring up a BGP session with anyone, the least you expect someone to do is go look up the WHOIS database, at least to see whether that address was delegated to someone or not, right? And that's what registries are supposed to do, bookkeep. Some do it well, some don't do it well. Let's be honest, our registries, internet registries, RIRs. And if people do it well, before I peer with someone, I go look up, and you have objects there. INET_num or INET6_num indicates that address space was delegated to that particular network, right? Not ownership, custodianship. Many people seem to confuse delegation with ownership. So you go look up, and based on that, then you bring up your filters, then you start bringing up your BGP sessions, right? So that's a classic WHOIS lookup. And the most well-abused, well-used is your IRR, right? Internet Routing Registry. Again, the idea with the IRR is Once I have an address space delegated to me, I go publish my routing intent in a database called the IRR database. It's just an intent, though. My intent might change tomorrow, but we don't go and update our route objects in the IRR database, right? So what you see in a typical IRR database is route or route 6 objects, right? Where I say, okay, I am the custodian of this address space, V4 or V6. I plan to announce from this to this length, prefix length, and I will nominate this AS as the one that will originate. Many of us inherit networks, right? Some of the route objects and route 6 objects were created by our predecessors, and we have hardly updated. Many people don't go and update their route objects out there. Now, the good thing about IRR is it allows me to auto-craft filters, right? I can use RPSL tools like BGP Q4, Q3, and if there are people who were 20, 30 years BGP folks, you might be using RTconfig as an RPSL tool to auto-craft these filters. The logic is very simple, right? If there is an object in the IRR database, I will accept. But it's also a flawed logic. What if you did not go create a route object in the IRR database, which means my filter won't allow you in? Right, so please, if you are using IRR as a filtering mechanism, be very careful. You might want to talk to whoever you want to peer with and say, hey, I don't see a route or route 6 object from your end. Was it intentional? Because if you're using RPSL tools, you will not allow those routes. Right, the idea is very simple. Your RPSL tools will go look up the IRR database, pull up your route or route 6 objects, and then it'll create a permit prefix list. Right? I've given you some examples of birds. What's important here is, I don't know if I can point laser. The source attribute is very, very important. You don't want to go look up an IRR database that is not authoritative or that's not trusted. So you might want to be very specific and say, if I know that the peer that I'm peering with is in the Afrinic region, you might want to point it to Afrinic as the source so that you only get authoritative route objects. Because if you go look up RADB, you might go pick up route objects that may not be authoritative or correct. Right? The other object that we also find in our IRR database is a proxy object, a proxy aggregate object called the AS set object. And many of us tend to use the AS set object to filter inbound. Especially if I am a transit provider or a regional provider, I might have many ASNs behind me. So instead of people wanting to ask me for a list of all my customers and their prefixes, they will ask me to go create an AS set object, which is a proxy aggregate object, right? And then they will use that object to craft filters. The logic is, again, very simple. Go walk through each member ASNs I have in my AS set object, and they'll do an inverse lookup, go look up route or route 6 objects for each of those member ASNs. Right? And the idea is I can either craft a prefix filter or I can either craft an AS path filter out of it. But AS set is a very, very dangerous object to use if you don't validate. Here is an example. Bharti Airtel. I'm not calling them out, but they are one of the largest networks in the world, right? About 3 to 400 million subscribers. If I were to peer with them and if I rely on this AS set, look how much it breaks down to. Close to 70,000 ASNs behind them, close to 2 million IPv4 routes, bigger than the internet, and even V6, close to 1 million routes. Look at the CIDR report as of 13th of April when I started writing these slides. The whole of internet BGP table had only 78,000 ASNs. And our IPv4 was close to 1 million prefixes. But if you were to peer with that network, you would receive almost 2 million IPv4 prefixes. Where did all those come from? Perhaps includes every bogan that's out there, includes every RFC 1918 address space, or maybe includes crazy prefix lengths, you don't know, more aggregates. So you would want to be very careful if you want to use AS set. Right? Don't just go use RPSL tool, craft a filter, and you use automation to slap it on your inbound or outbound interface. So. The other problem with AS set has a lot of problems, as you can see. The other problem with AS set is what we call name collision, right? Many people tend to not create hierarchical AS set names. Example, this was a problem I was solving in Mongolia. My friends from Gemnet, they said, oh, my traffic from one of the CDN providers has dropped. most of the big providers, they tend to have filter updates every 6 hours or every 8 hours or every 12 hours. They will recycle their filters. So they go look up your AS set in our IRR database, and what had happened, somebody in the Czech Republic had created an AS set with the same name. This was in Mongolia, this was in the Czech Republic. Look at the member ASNs behind this one. There are only 2 ASNs. Look at how many member ASNs I have behind the genuine one in Mongolia. So all of a sudden, you lose massive traffic, inbound traffic from that provider, right? So you want to create what's called a hierarchical AS set. This RFC is as old as many of us in this room, right? The first RPSL RFC, which clearly recommends you to go create a hierarchical AS set. I'm using Vocus here as an example, and this is the right way to create. With your AS number, and then put whatever you want to put, and within that, you create your member ASNs, add your member ASNs. So if you already have a non-hierarchical AS set like this, there is a mechanism for you to transition to a hierarchical one. Create a new AS set, make sure the members of your old and the new AS set matches, add your new AS set as a member of the old AS set. From then on, you don't have to touch the old AS set, keep updating your new AS set. In the meantime, go talk to your eBGP peers, update your peering DB, and maybe a month or 2 later, delete your old AS set. But don't just go blindly delete, then you don't appear in the IRR database, which means I don't see you, right? Again, back to basics. Since it's really difficult for us to identify what is bad, no evil bit and the rest, we then try to approximate what's good. Many of our security tools actually try to do that, right? We try to estimate what is good, assume anything outside of that is bad, drop it, right? So there are tools that allow us to do this. One of the most important tools that we have recently is BGP roles, RFC 9234. One of the best tools or best proposals, I think, because even without me configuring a policy, if your platform supports RFC 9234, it will automatically help you prevent route leaks. Right? The idea is very simple. Define your role against your BGP neighbors. If I have a provider, mark myself as a customer. If I have a peer, mark myself as a peer. Right? So the allowed roles are either I'm a provider to downstreams, my local eBGP speaking router, or either I'm a customer to my upstream, I'm a peer to my peer, I'm a route server to a RS client, or I'm a route server client at an internet exchange, right? And the only allowed relationships are provider to customer or customer to provider, peer to peer, route server to a route server client, or a route server client to a route server. And how difficult is it to configure? On your local eBGP speaking router, just define your role. If this is an eBGP speaking router that I'm talking to my upstreams, define myself as a customer, that's it. This is on Junos, this is on FRR, right? Ask your vendor. You are the ones paying your vendors. If your platform doesn't support it, maybe you want to push your vendor to make sure that it supports RFC 9234. And the beauty of RFC 9234 is it codifies it. You don't have to do anything. All you need to do is define your local role, and it does the magic for you. Assuming they implement the RFC correctly, right? Vendors don't seem to do that well. So once that is configured, then you have an attribute that we call only to the customer attribute, or the OTC attribute, right? And we don't have to configure that. I just need to configure my local role, and the algorithm takes over, right? And the way we set the attribute is, before I send a route to a customer, peer, or a RS client, I just mark a route with the OTC attribute. Only to the customer you're indicating, right? You're indicating to your peer that, hey, you're allowed to send this route onwards to your customers, but not to your upstream. That's the logic, right? And on the inbound side, if you receive a route from your upstream provider or your peer or from a route server, and if there's no OTC attribute set, then you mark it, right? And the check is straightforward. Check is very straightforward. On the outbound side, if a route is marked with the OTC attribute, do not send it to your upstream. Only send it to your customer. That's what the attribute says, right? And on the inbound side, when you're receiving routes from your peers, if you receive that from a customer, if you receive a route from a customer with the OTC mark, probably it's a provider-to-provider leak. I might be a customer, I might have 2 upstreams, I receive that route from my upstream with the OTC marked, and I'm leaking that across to my other provider. So if you see that, you can actually discard that route and you can prevent route leaks. Right? It's a very powerful tool. And what does it have? It only actually has the AS of the sender. When you go look at the OTC attribute, it just has the sender's ASN in it. Right? Then that brings us to RPKI, right? Chain of trust that you build. And the first one that you do is route origin authorization. Me as the custodian of an address space, I can nominate any ASN that I want to originate that on my behalf, and I digitally sign it. Right? That's what a ROA is. And the idea with that is, instead of me just filtering against route objects, now whenever somebody sends me a routing announcement, I look it up. I look up the ROA database, compare, look at the prefix. If it matches, great. Look at the origin AS. If it matches, great. Then I also look at the max length. Is the prefix length correct? If all of those match, it's valid. If either the prefix length or the origin doesn't match, it's not valid. And if people are still lazy to create a ROA, I can't go look up a ROA in the database. I mark it as unknown. Right? When I was at APNIC in my previous life, we did a lot, almost 7 years of ROA deployathons, ROA signing BOFs. I'll give you a T-shirt. I'll buy you a beer. Please sign your ROA, right? But be very careful. ROA, some people just say, oh, just go create a ROA. You would want to be very careful. If I run a multi-AS network, I might have a transit AS. I might have access ASNs. Right? For my mobile network, maybe a AS. For my data center network, maybe AS. Those are all access AS for me. Many people tend to create ROA only for the transit AS, but you originate those routes from your access AS, and you are invalidating yourself. The other side who is validating will go, hey, the nominated origin AS is only the transit AS, but the actual more specifics are coming out of your access AS. So there are certain best practices you would want to follow when it comes to ROA creation also. Some people are very lazy. They misuse the max length attribute. /32 v6 all the way to /128. Why even bother creating a ROA then? Because you allow me to do all more specific hijacks because your ROA says I'm allowed to do that, right? Probably one of the best proposals from the RPKI group was BGP-sec. Because I can spoof origin AS, it's not difficult to spoof, which means it will always be marked as route origin valid. But I also need to somehow find a way to secure the path. And RFC 8205 BGP-sec, I think we are not ready for this algorithm. The algorithm is beautiful, but we don't have the hardware to do this at the moment. And the idea is very simple. When I announce something to my next hop, sign that. When my next hop announces that onwards to others, they create. So we end up creating this chain of signatures. And if you're at the receiving end, you decrypt this chain of signatures and you validate the path. But the problem with that is you need to do crypto on the router. Right? With route origin validation, the crypto is handled by my relying party, which is my RPKI validator. It only gives me a crypto stripped version to my router. My router doesn't have to do any crypto, which is why ROV works really well. But with BGP-sec, your router needs to do all the crypto. I need also to find a way. Every eBGP speaking router, I need their keys on my eBGP speaking router, right? So brilliant idea, but maybe perhaps we are not ready. Maybe 10 years from now, we might have hardwares that can do it. But at current stage, my router might be as big as a car for me to be able to do this, right? Unless you have shares in the vendors, we don't want to implement BGP-sec yet. So that brings me to the final puzzle piece, right? Which is, so BGP-sec is for the future, whenever we are ready, whenever hardwares are ready. So for the interim, people came up with a per hop validation, which is ASPA, AS path validation, right? Autonomous System Provider Authorization. It uses the same RPKI framework, the same RPKI chain of trust. In ROA, we said, me as a custodian of this address, I nominate this origin AS to announce my route. With ASPA, I'm a customer, I nominate my upstreams. So if I have two upstreams, I add them as my providers, right? I am the customer AS, and I sign that object, and that object is what we call ASPA. Here is an example of Cloudflare. This is their customer AS, and they are telling the world, these are my 3 upstreams, and they sign that, right? There are also special AS0 ASPAs that you will see. If you're a tier 1, you may not have a transit provider, and to indicate to the world, you mark AS0 there. Even with ROAs, you have AS0 capability. If I have unused space, remember Orange was getting hijacked, their unused /15 was getting hijacked for last 2 weeks because there was no AS0 ROA for that. So if you have unused space, I wonder why they even have a /15 unused. Sell it off, make money, or give it to me, right? But they could have gone and nominated AS0 ROA for that unused address space. And whenever somebody tries to hijack, if I see that ROA, your AS0 says not to be routed, is what AS0 means, right? But yeah, it seems they didn't do it. But in ASPA also, we can use AS0 to indicate to the world that I have no upstreams. I am a tier 1, right? And and good thing about ASPA, again, is no crypto on the router, because my validators do all the hard work. They will pull all the ASPA objects, decrypt all of them, and the validated payload is what comes to my router, right? So my router does not have to do any crypto on it. And ASPA algorithm is a bit complex, right? They have this concept of up ramp, they have this concept of down ramp, but we don't have to know that, because if the vendors implement it correctly, the algorithm is the code is supposed to do that, right? But the logic is very simple. Upstream from me, customer, to the provider. At each hop, you look at the customer AS, you look at the next hop, and look at ASPA data to see if the next hop is in the list of my provider AS or not. If it is, it's valid. If it is not, if my ASPA data says for Cloudflare, only this one, but for some reason, if the next hop is AS6939 or some other AS, your ASPA is saying this is not my provider, it's invalid, right? And right now, many RIRs are not ready, except for RIPE and ARIN. Most RIRs don't have a way for you to create an ASPA object, so majority will be marked as not found because I can't go find an ASPA object. Right. But this is up-ramp, customer to provider. And now it helps with spoofed origin AS. In this simplified topology that I'm sharing here, AS1 on the right-hand side is the genuine, but somebody is trying to spoof as AS1 on the other side, and they're trying to. Your ROV will mark this as valid. Look at the prefix, look at the origin AS, they match. Oh, route origin valid. But with ASPA, I can now detect the spoofed origin attack, right? Because I look at all the ASPA objects. AS1 has marked AS2 as its upstream. AS2 has done the same for AS3. AS3 is a tier 1, no upstream. AS4 has marked AS3 as upstream. So if I'm validating this at AS4, I see 2 paths. One coming from the spoofed origin with a path attribute of originated from 1, came via 5 to me, and AS4 also received it from the other end, which says originated by 1, came through 2, came through 3, but based on ASPA, I know that AS5 is not a provider for AS1. Spoofed origin, drop the packet. Right? So you prevent this kind of spoofed origin attacks. This is the complex part of ASPA, there's this downstream path validation, and this concept of a valley-free routing, right? Typically, if I'm a downstream, you're a downstream of somebody, I'll have my providers, my upstream might have their upstreams, and eventually we all meet either at a common upstream, maybe if we both share a common tier 1, or our 2 upstreams might peer with each other, right? But there is no valley, as you can see. We will either meet at a common peak or we will meet at 2 upstreams who peer with each other. Whenever there is a valley, up, down, that means somebody is leaking it somewhere, right? If I have 2 upstreams, what I learn from one upstream, BGP will automatically start leaking that to my other upstream, then you form what's called a valley. So that's how you detect route leaks, right? And the way ASPA finds it is that if it looks at the up ramp, it looks at the down ramp, and if it does not meet at a common tier 1 or at 2 providers, adjacent providers, it assumes there was a valley and it's a leak, right? This might explain it a bit better. In this case, AS4 has 2 upstreams, AS3 and AS5. Whatever routes it learned from AS3, it is accidentally leaking it out to its other upstream, AS5. But ASPA is able to detect this leak because I plot the path on the up ramp. I look at the AS path, originated from 1, transited 2, transited 3 before I learned it. On the down ramp, ASPA data says I should only have 5 to 6. So there is a gap. AS4 is the gap. So the way ASPA looks at values is if there is a gap, if it does not meet either at a common upstream or between two adjacent peers, there is a gap. That gap is assumed to be a route leak, and then it marks it as invalid. Right. Timeline-wise, I did this 2 years ago. The timeline hasn't changed. Right. The ASPA main document is pretty much, I think, ready, but it's more the RTR from your validator to the router. They have had to rewrite that. So the version 2 is almost ready, and hopefully by end of this year it's ready. RIRs are not ready, right, except for Arian and Ripe. APNIC, my former colleagues, they tell me by Q2, end of Q2, or by Q3 they should have a dashboard ready. I don't know about Afrinic. If there's anyone in this room, you might want to push your RIR to give you an ASPA dashboard, right? When it comes to RPKI validators, pretty much all well-known validators are ready. They have been ready 3 years ago, right? And when it comes to your commercial BGP speakers, talk to your vendors. Pick your poison, whatever poison you use, push them. Tell them that we need ASPA support, right? Because routing daemons already do it. FRR does it, Bird does it, but it's the commercial routing vendors who don't seem to do it yet. Right. Now, quickly, advertising route views. When things go wrong, we need to go back in time to understand what happened, how it happened. And for that, researchers or analysts like myself, we need access to BGP historical data. And route views is the world's oldest route collector. Right? It has been collecting routes BGP timestamp for last almost close to 30 years, and it archives that data every 2 hours. Right? And there are many commercial tools that actually use route views data, but they don't acknowledge that. Maybe it's time folks acknowledged, because the underlying data is still route views data, right, with all these commercial tools out there. Just quick look at Africa, where the collectors are. There are only 4 collectors in the whole of this continent, right? We might want to increase that. We might want to do better with that. So route views definitely is looking to have new collector locations. Either IXP or a member of the IXP can host that. And to peer with route views now does selective peering. In the past, it didn't. Because there are hobby networks who also want to peer with route views, and you don't get any visibility from those networks. So route views now does selective peering. And if possible, please give route views the full BGP feed. Even if you're not at an IX, you can do multi-hop. We host 2 or 3 collectors in University of Oregon that allows you to do eBGP multi-hop. Right. That's my talk. Thank you.
Thank you so much, Tashi. Does anybody have any questions? Yes, please come through to the mic.
Hello, my name is Mark Elkins. I am a member of Afrinic. Afrinic doesn't yet do ASA. ASPA. Can we please have ASPA? Thank you.
Yeah. I also second that.
Hi, my name is Donald Jolly. I have put on my work online communications hat and also asking the same thing of Afrinic. But more a question to you, because this might be something that Afrinic might say, is that ASPA is not yet ratified. So why should we be implementing it on our systems? What would you say to that?
Yeah, that's a really good point. Like I said, the ASPA document, the main ASPA document itself, I would assume is ratified, although it's not yet at the IETF, because the document hasn't changed in the last 4 or 5 years. The standard is solid. The main ASPA document. It's the RTR that is taking more time, because some well-known names are involved, the likes of Randy are involved, and the previous RTR that they wrote. So convincing some of the seniors takes time, and having to change that code, because your previous validators only knew how to strip a rower, but now it also needs to have that ability to strip ASPA objects, the crypto part. So that is the part that's taking, hopefully by end of this year, it gets ratified. But I think Donald makes a good point. But I think RIR can still prepare itself, talk to other RIRs, because RIRs have inter-RIR working groups, where if RIPE has done it, ERIN has done it, APNIC is doing it, why not the other two, LACNIC and AFRINIC?
Good afternoon. Actually, yeah, good afternoon. Hendrik Versage, I'm from AFRINIC member. Question on this, can we implement it ourselves if we have a delegated RPKI?
Yes, you can. Krill already supports that capability for you to run a delegated mechanism. But the chain of trusts can't still be broken. Even if you run a delegated RPKI, that delegated one needs to have been delegated by someone, right? So as long as the chain exists, great. But if the chain doesn't exist,
Just last comment here as an AFRINIC member. Can AFRINIC members please ask AFRINIC for delegated RPKI?
Yep, correct. Thank you.
So, thank you so much, Tashi.